All right, let's go ahead and check out knowledge check 4.3.3. So the first step in this is use the C, or the concatenate function, to create a vector called weight containing the weight of 10 children. And we've got the weight values here. So I'm going to go ahead and just copy these values and then come down here, and we're going to call this weight. And I use the concatenate or combine C function and go ahead and fill in the values. And we can see now we have a vector that contains the values I put in that C function. All right, next up is extract the weights for the first and last child. So there's actually a couple of ways we could do this. One is we can always index for the first position using 1. And we know that there's 10 values in this, so I can always get the last position with the 10. But to get both of them, what I need to do is to supply a vector with the first and last index values, 1 and 10. So now when I run that, I do get both the values, 75, which is the first, and 99, which is the last. Now, thing is, we may not always know how many values are in a vector. So there is a function that is called length, and if I apply that, it tells me how many elements are in that vector. So what I could do is, if I didn't really know just how many elements were in a vector, instead of specifying 10, because we don't know, is there 10, is there 11, is there 20, I could just go ahead and do length weight. And now this is going to take the first element and the last element. All right, next step, extract the weights for the first 5 children. So to do this, we can just go ahead and we can create a sequence 1 through 5. Recall that if we do 1 through 5, that just creates a sequence that goes from 1 up to 5 with the discrete integer values. So I can just supply that in my brackets, and I see down here I get my values for the first 5 elements. All right, the last one was extract the weights for those children that weigh over 90 pounds. So we can do logical expressions, and when we do that, so if I just wanted to say basically my vector weight greater than 90, what that actually does is it's going to provide a vector back of true false values, and it's going to tell me for each element within the weight vector, does it meet this condition? Is it greater than 90? We see we get false, true, true, false, and that would align to what we see up here for the values. So now to get those values that are over 90, or basically we're trying to get those values that equal the true in this logical expression, I can just go ahead and include that in my brackets for the indexing. And now it'll return just those elements where the logical expression is true. So we see now all our values are greater than 90.